China just dropped a lineup of humanoid robots that's making the rest of the world nervous. From AI systems that teach robots to think like humans, to mechanical beasts pulling cars with their bare metal hands, to industrial workhorses already replacing factory workers by the thousands, China's robotics game just went up a notch. However, what's even crazier is the fact that our number one robot in this video costs just $1,370. Yeah, $1,370. Less than a flagship iPhone. And it might just flip the entire robotics industry on its head. But before we get to that, let's kick this off with something that sounds like science fiction, but is very much a reality. China just unveiled an AI system called WOW. And no, that's not me being dramatic. That's literally what they named it. It stands for World Omniscient World Model. And honestly, the name fits because what this thing does is actually pretty wild. It's being called the world's first self-evolving multimodal world model system. Now, before your eyes glaze over from the tech jargon, let me break down why this matters. WOW was developed by the Beijing Humanoid Robot Innovation Center, working together with Tsinghua University and the Hong Kong University of Science and Technology. On paper, it's a combination of a physical simulation model and a vision language model, but in practice, it's basically teaching robots to have physical intuition. You know, that thing humans have, where we just know that if you push a cup too close to the edge of the table, it's gonna fall and make a mess. Yeah. WOW gives robots that same gut feeling. The idea behind it is actually fascinating. Current video or simulation models just watch the world passively. They can see what happens, but they don't really grasp why it happens. It's like watching a cooking show versus actually knowing how to cook. WOW flips that approach entirely by letting the model actively interact with its environment, learn from it, and refine its understanding through trial and error. It's a 14 billion parameter generative model that actually learns about physics the way we do, by doing things, messing up, and improving over time. The team behind WOW built it on something they call the Sophia paradigm, which combines large language models with diffusion transformers to generate physically accurate outcomes under language guidance. So if you tell a robot to move a cup off the edge of the table without spilling it, WOW doesn't just output words or animations like some chatbot having an existential crisis. It predicts what would happen, checks the result through reasoning, and refines its understanding to make the next move more realistic. To test all this, they even created a whole new benchmark called WOW Bench. It measures how well AI systems can understand perception, reason about predictions, make decisions, and execute them in a generalized way. So far, WOW has hit state-of-the-art scores on that benchmark. It beats other models in physical plausibility, temporal consistency, and understanding complex instructions, which is a fancy way of saying it doesn't do stupid robot things like trying to pour water into a cup that's upside down. One of the coolest things the researchers demonstrated is how WOW can be used in areas like novel view synthesis and trajectory-guided video generation. Basically, the model can simulate what an object would look like from another angle, or how it would move in a real scene, all with consistent logic behind it. They even showed how WOW can enhance the planning abilities of vision language models by providing simulated feedback, helping them plan tasks more efficiently. It's like giving a robot the ability to mentally rehearse before doing something, the same way a gymnast visualizes their routine before competing. The authors of the paper made it clear. This is a crucial step toward building AI systems with genuine physical common sense. When robots have access to massive real-world interaction data instead of just videos or text, their understanding of cause and effect becomes far more grounded. That's the missing link between today's chatbots and tomorrow's embodied intelligence. Robots that don't just see and describe the world, but actually live in it, learn from it, and make independent decisions. And here's the thing. WOW isn't just some lab experiment collecting dust in a research paper. This is the foundation powering the next generation of Chinese humanoid robots, including our number one pick, which cost just $1,370. But we'll get to that absolute game changer at the end. Trust me, you're going to want to stick around for that reveal. Now, let's talk about robots that are already working real jobs, making real money, and replacing real humans on factory floors across China. Meet the UBTech Walker S1. Developed by Shenzhen-based UBTech Robotics, this full-sized humanoid stands about 1.7 meters tall, and it's built for industrial manufacturing, tackling repetitive, physically demanding, or hazardous jobs that humans find tough or risky. Imagine a tireless factory worker, tall, sturdy, and smart enough to handle the messy, unpredictable parts of a production line that regular machines can't touch. Now let me show you what this thing can actually do. The Walker S1 glides into frame with a steady, human-like stride, arms swinging naturally, head scanning the warehouse floor like it's mentally cataloging every detail. It steps confidently onto a moving conveyor belt, checks if the seatbelts are okay, then moves to the front of the car. There, it gently fixes the car emblem with precision. That's not CGI, that's actual production work happening right now in Chinese factories. It can climb stairs, carry loads up to 20 kilograms, and even walk on a treadmill while juggling parcels, all thanks to end-to-end AI learning that mimics human balance and motion. The smart brain inside uses large language models for task planning, so it understands instructions like, pick up that tool and tighten this bolt, without needing anyone to program every single motion. Integrated sensors for vision, force, and spatial awareness let it navigate cluttered factories, avoid obstacles, and collaborate with other robots or humans. It learns from real-world trials, improving over time. If it fumbles a delicate part once, it adjusts its grip strength next time. If it slips on an uneven floor, it remembers and compensates. It's basically getting a PhD in factory work, on the job. But why does China need these so badly? China is facing a massive labor shortage, projected to need about 31 million skilled workers by 2035. The Walker S1 handles assembly tasks that fixed robotic arms struggle with, performs inspections and logistics work with 99% accuracy, and takes on hazardous or repetitive jobs in hot, noisy environments. It's already deployed at BYD's Changsha factory, working at Zeekr's 5G Smart Factory and FAW Volkswagen's Qingdao plant, and even partnering with Foxconn for iPhone production pilots. And when Foxconn starts using your robots, you know you've made it. Orders have exploded. Over 500 units from automakers alone in 2025, totaling more than $112 million. The price? Around $34,000 to $41,000 per unit. Compared to Western rivals that cost upwards of $150,000, it's an absolute steal. Mass production is ramping up to over 1,000 units by year's end. The Walker S1 is proof that China isn't just playing catch-up in robotics anymore. They're setting the pace and forcing everyone else to scramble. Alright, let's shift from the factory floor to something more elegant. If the Walker S1 is your blue-collar workhorse, then XPeng's Iron is the white-collar professional showing up in a tailored suit. A robot that glides like a fashion model, but could one day guide you through a store or check your home's appliances. That's XPeng's Iron, the electric vehicle giant's bold bet on embodied AI. The second-generation model, unveiled in November 2025, stands 178 centimeters tall and weighs just 70 kilograms, designed for commercial and light industrial service roles. And when I say it moves gracefully, I mean it's almost unsettling how human-like it is. The Iron has over 60 joints and more than 200 degrees of freedom, more articulation points than a professional dancer. It can strut with a natural sway, twist its biomimetic spine like it's doing contemporary dance, and flex muscles. The hands alone have 22 degrees of freedom for delicate tasks, like handing over a product without crushing it, or typing on a screen without breaking the keyboard. Under the sleek exterior, it runs on 3 in-house Turing AI chips, packing a combined 3,000 TOPS of computing power, which is more processing muscle than most gaming PCs. It operates on a Vision Language Action (VLA 2.0) model, processing sights, words, and actions in real time. It can chat naturally, predict needs like, "You look lost, follow me," and learn physical intuition from human-like datasets, adapting to crowds or uneven floors. Now, here's where XPeng's CEO gets brutally honest. He straight up said, "With cheap Chinese labor still available, Iron skips heavy factories or homes for now because it's too pricey at scale." Translation: why pay for an expensive robot when you can pay a human less? Instead, Iron targets human-centric commercial spots where flexibility and presentation trump raw power. It's acting as tour guides in XPeng showrooms, sales assistants in retail greeting shoppers, or office receptionists using its 3D head display for expressive eyes to build rapport. Price? Iron is projected at around $150,000 for early units, reflecting high-end hardware like all solid-state batteries. Mass production is expected to commence by the end of 2026, with an open SDK for developers. XPeng is committing up to $13.8 billion over 20 years, betting that costs will drop as volumes rise. I like the Iron because it shows that not every robot needs to be a factory beast. Some can be sophisticated service providers for spaces where appearance, grace, and social intelligence matter as much as raw capability. Speaking of raw capability, let's talk about something with ridiculous strength packed into a tiny frame. Unitree's G1 is over here showing off like it's trying out for the Robot Olympics. Over at the Beijing Academy of Artificial Intelligence, researchers took Unitree's G1 humanoid and gave it a challenge that sounds like something from a strength competition. Pull a real vehicle weighing 1,400 kilograms across a flat surface. Now, before you say, "Yeah, but cars on wheels roll easily," let me give you some context. The G1 weighs just 35 kilograms and stands at about 132 centimeters tall. We're talking about a robot roughly the size of a large child, pulling a vehicle that weighs 40 times its own body weight. Try that at your local gym and let me know how it goes. Granted, the car was on smooth ground, so the friction was low, but still, the balance and control required for that are absolutely next level. Because it's not about brute force here, it's about dynamic stability, real-time adjustments, and not face planting into the pavement while you're trying to show off. What's genuinely impressive isn't just that the robot could move the car, but how it did it. In the video, you can see it leaning back sharply, moving its feet rapidly to maintain traction like it's doing some weird horizontal tango, and constantly adjusting its posture to stay upright. And it's doing all of this autonomously. No one's controlling it with the joystick, no cables holding it up. It's pure robotic determination. And this kind of dynamic balance is absolutely key for humanoid robots working in human environments, warehouses, factories, or even rescue missions. A robot like the G1 could carry equipment across uneven ground, step over debris, or help move objects without tipping over or losing control. Now, let's be honest about the limitations because it's not all robot superhero stuff. Even with all this progress, most humanoid robots, including the G1, still struggle with hand dexterity. They can walk, run, jump, and apparently pull cars, but doing delicate tasks like buttoning a shirt or picking up a fragile object without turning it into dust, still far from perfect. It's that uncanny valley of capability. They can do superhuman things, but struggle with tasks a toddler masters. Developers are focusing hard on making these movements more natural and safe for work environments, but we're probably still a few years away from seeing them rolled out widely in everyday workplaces where fine manipulation is critical. The G1 represents the democratization of advanced robotics. It shows that sophisticated locomotion, impressive strength-to-weight ratios, and dynamic balance don't require a six-figure price tag or a robot the size of a refrigerator. Compact, capable, and increasingly affordable, that's the direction the industry is heading. And speaking of affordable, oh boy, do I have news for you about our #1 robot. Remember, at the beginning, when I teased a robot that costs less than a flagship iPhone? Well, buckle up, because Beijing startup Notix Robotics just dropped what they're calling the world's cheapest humanoid robot. Meet Boommy. It costs 9,998 yuan. That's $1,370. Cheaper than a high-end gaming laptop, more affordable than some decent drones. Hell, that's cheaper than most people's monthly rent. And yet, this thing can walk, balance, and even dance with a level of stability that would have cost you 50 grand just 2 years ago. Now, before you think this is some cheap toy or a flimsy proof of concept that falls apart if you look at it wrong, let me set the record straight. Boommy is a real, functional humanoid that stands about 94 centimeters tall and weighs around 26.5 pounds. Notix Robotics isn't trying to compete with the big industrial machines or the fancy service robots. They're not going after factory contracts or luxury showroom deployments. They're opening a whole new category that nobody else is touching. Small, lightweight, and affordable humanoids built specifically for education and home use. They looked at the market and said, everyone's building robots for businesses and factories. What about regular people? What about schools? What about families who want to experience this technology without taking out a second mortgage? Early videos show it moving with a smoothness you wouldn't expect from something under $1,400. We're not talking about jerky, robotic movements that look like stop-motion animation. This is fluid, controlled motion that suggests some serious engineering went into that affordable package. The company proudly states this is the first consumer-grade humanoid priced below 10,000 yuan. And honestly, it could mark a genuine turning point for the whole industry. Because let's be real, most humanoid robots capable of walking or dynamic motion still cost tens of thousands in China and even more in the West. Boston Dynamics robots, 6 figures, easy. Tesla's Optimus, projected at $20,000 to $30,000 when it eventually ships. Even China's other affordable options hover around $16,000 to $20,000. So how did Notix pull off this pricing miracle without building a piece of junk? Clever design choices and strategic decisions. They used lightweight composite materials instead of expensive aerospace alloys. They developed an in-house motion control system rather than licensing expensive third-party solutions. They built a modular structure that's easy to repair and customize, reducing maintenance headaches and costs. Most importantly, they made strategic trade-offs. Boommy focuses more on engagement, learning, and educational applications than heavy lifting or industrial tasks. It's not trying to pull cars like the G1 or work 24/7 on a factory floor like the Walker S1. It's designed to be a learning companion, a coding platform, and an introduction to robotics for people who could never afford the alternatives. And this isn't Notix's first rodeo. Their earlier model, the Notix N2, already sold over 2,500 units and even completed a half marathon for humanoid robots earlier this year. That success helped them position themselves among China's fastest rising robotic startups and validated their approach of targeting education and enthusiast markets rather than industrial clients. With Boommy, they're clearly going after mass adoption in a way nobody else has dared to attempt. The robot runs on a 48-volt battery with a capacity of over 3.5 amp hours, giving it about 1 to 2 hours of operation per charge. Not enough for industrial work, but perfect for classroom demonstrations, coding lessons, or interactive learning sessions. It's designed to support drag and drop graphical programming, so even kids or complete beginners can code it easily without needing a computer science degree. What we're witnessing isn't just incremental progress. It's a fundamental shift in how humanoid robots are designed, priced, and deployed. The combination of advanced AI like WOW, practical industrial applications like the Walker S1, sophisticated service capabilities like the Iron, impressive demonstrations of capability like the G1, and barrier-breaking affordability like Boommy creates an ecosystem that's moving faster than anyone expected. And if this pace continues, then 2026 might really be the year when robots transition from expensive curiosities to practical, widespread tools. Not because someone programmed every single move, but because they actually understand what they're doing, learn from experience, and get better over time. The future isn't coming, it's already here, walking on 2 legs, and it costs less than your laptop.